someone tell me what this is? Stella, what is it? What is this? So this is one of the instruments or devices that we commonly use when it comes to dealing with charges. This instrument is said to be called a gold leaf electroscope. We just have seen that from the gold leaf electroscope, it is a device which has the structure there. It is used to detect presence of electric charges on a body. So if there's a body that has charge, and then you actually want to know whether this body has got charge or not, in order to detect, you use this instrument. So it comprises of the metal cap. First of all, it comprises of the metal cap. You can see the metal there, that's said the brass cap, metal or brass cap. So sometimes we use, instead of the metal, a brass. So brass is one of the metals. And then we find in some books or some good packages from where we can be able to get a lot of information about this, tell us that we can also be able to use copper. So you find somewhere, some books say it is copper cap or metal cap or even brass cap, but all that we know is it is a metal. Then this metal is connected to the brass plate or the metal plate also. But somewhere there's a rod that connects that plate to the metal cap. It is called the brass rod or the metal rod. It is also made out of metal. See this one here, this is the metal or the brass rod. Then we have the gold leaf. The gold leaf is actually attached. It is fixed onto the metal plate. So we have somewhere here the insulator, which is connected on the brass rod or the metal rod. This helps to stop the contact of charges. You'll find that when this metal has already charges here around here, to avoid these charges being conducted away, we remember that metals are all good conductors, and even including we human beings, we are also conductors. So when you just touch this or this contact from the metal case, of course, what has enclosed the gold leaf and the brass plate inside, what is used to enclose this is also a metal case. So the metal has to be broken, that contact with the metal rod or the brass rod, so that in case of charges that are induced here on the metal or the brass cap, it doesn't get conducted away through the what? Through the metal case. If we can just see a clear picture of, if this was to be an art thing, a clear picture of what an electroscope is what we have here. You find the metal case is here. It houses the gold leaf there and the metal rod. But you have the windows, see the two sides are open. These two sides are open in a way that they're made out of glass, so that you can be able to see whether there's a deflection of the gold leaf or there's not. The metal cap usually takes that shape. So when you go to the lab, the common gold leaf electroscope that we have in our various labs, they take that shape. They are like that. So you find it down here. We also have the insulator. This stops the contact of electrons or the contact of charges away from the body. So that is what we have for the structure. Just to move on, this, as I said, gold leaf is fixed together with the brass plate. So as it gets fixed there, you find the brass plate, the gold leaf, and the part of the brass rod. These I did say that are enclosed inside now the metallic case or the box. So with glass windows, I just had shown for you those windows. So the structure that we usually have in our descriptions is this. How does this gold leaf electroscope operate? What happens when a charged body is brought near or in contact with the metal plate? So that is now actually what takes us to the mode of operation there. So because we're saying it is the actual device that we use for detecting presence of charges, so what we usually find is that when a charged body is brought in contact here or near it, we very well know that charges can be transferred, or a body becomes, or another body becomes charged by conduction or by even induction. Those were some of the methods that we had looked at as far as electrification of bodies is concerned. It is one where we actually classified on insulators. Then later on, we had to double it with the conductors. Meanwhile, we have that now on the mode of action, or how this one works. When a charged body is brought near or in contact with this, you'll find if the charged body is brought near here, there's going to be induction of charges. Charge is going to be induced. We said that when a charged body is brought near another that is not charged, charges can get induced on this body. And so it's going to be the case with this. But you'll find the part of the gold leaf electroscope that is closer to the charged body, in which case here we have the brass cap is going to have similar, it's going to repel similar charges which are induced from the charged body here. So if in case the charged body you had brought here is positively charged, so it is going to be inducing negative charges around here on the metal or the brass cap. Meanwhile, the opposite charges to this will have to move or repel down to the brass plate and the gold leaf, and this move through the brass rod. So that is basically how it starts here. So a charged body, when brought near or in contact with the cap of the electroscope, the cap acquires a charge opposed to that of the body by now induction. And then what follows is that the charge which is on the body will repel all the charges similar to it. So I was saying if the cap was now positively charged, if the cap was in such a way that now the induced charges, the charges induced by that body which is being brought near the cap, the induced, that body was negatively charged, and then it induces positive charges on the cap, you'll find that around that area of the cap, negative charges will be repelled down to the metal rod and to the plate. And then you also find now through the metal rod to the plate and then the leaf, you find now because the metal plate and the leaf have acquired the same charge, because they have acquired the same charge, they will be able to repel. So the repulsion there will be regarded as divergency of the leaf. So the leaf tries to get off or away from the gold, from the metal plate. So the leaf diverges as it is repelled by the plate. This is simply because they have the same charges. Now from there, we shall be able to conclude that the body which has been brought near the near the cap of the electroscope, or which has been brought in contact, has got a charge. So that is what we always have to remember when we're talking about the mode of operation of the gold leaf electroscope. And then there's a point that I actually want to bring here. Why we prefer to have different metals here. we can see that for the metal cap and the rod, we said we can use we can have a metal, any metal, but preferably we always go with the brass or we go with copper. But when it comes to the gold leaf, we make the leaf, that small leaflet, we make it out of gold. We even very well know that gold is a very dense material. It is a very heavy material, but we prefer making that out of gold, and then the deflection can easily be measured even from there. I want to ask a question. Why do you think we prefer using gold to make the gold leaf other than those other metals? Who can give me an answer? Or who can try? Why we prefer to have the gold leaf or the leaf made out of gold as the material for the leaf made out of gold, but not other substances or other materials? Can give me an attempt? Peter, can you try?
I think it's a poor conductor.
I beg your pardon.
I think it's a poor conductor.
Gold leaf, you're saying gold leaf is a poor conductor. I mean, gold is a poor conductor. Good trial. Another? Who is trying to come up with an answer? Some answer? Can we have Sharon try? Albert, what about you? Stella, you can go ahead.
Because
yes,
because it is heavy. Yeah, I think that's why
so
we
the
use
reason
it, because
is because it is heavy.
Because it.
There she. I've got what you've said. Ben, you're trying to speak up. I think you've got you seem to have got something to say here. When we go to, I know, when we move to have concepts in chemistry, Ben, you can mute your mic because we can't get you, and then maybe probably have your view there given it from the chat section. I'll be able to read. When we look at the reactivity series, especially when we take air, the reaction of air with other substances or with other with the other in chemistry, you'll find that mercury, I mean not mercury, but gold does not react with air. Gold does not react with air. So one advantage that we always have here is because gold does not react with air and there's always air there, so it is not going to be affected by air. The deflection there is not going to be affected by air. So its deflection there, or the divergence, the level of divergence there will not be affected by air because there's no reaction that gold can undergo with air. It is not possible. So secondly, we say that gold is ductile. What are ductile materials? What are ductile materials? someone might have looked at properties of materials, the mechanical properties of materials, and then one of those properties we talk about is ductility. Who has an idea on what these ductile materials are? How do these ductile materials behave? What happens when you try to break a material, and then you find, and in fact, you try to break a material, but you find this material does not easily get broken, but it only bends. What type of material do you end up saying? I mean, how do you regard that kind of material? How do you describe that kind of material? A material that you always want to break, but you find at the end it does not break, but it only bends. How do you describe that type of material? Amira, can I hear from you? So this is where we shall say that material is ductile, because when we try to break it, it only bends. It does not break, it only bends. So you find that when you try to break gold, this gold will only bend. It is not very easy to break gold. It only bends. So because of this advantage, because it is like that, and then actually the greatest advantage is when this is done to produce very thin leaves, because you find that the gold leaf is just very thin. So when this is done to produce those very thin leaves, that advantage is there. So because of that, we always consider now having gold. Now I want us to leave, I have this concept of trying to charge the gold leaf electroscope. The gold leaf electroscope can be charged either positively or it can be charged negatively. Just like when we had our last lesson, we did look at how to charge bodies negatively by induction or positively by induction. I think that's what we look at. And then also similarly here, when a gold leaf is not having a charge, you can be able to charge it and then it becomes charged. It either takes a positive charge or it takes a negative charge. And usually we say a gold leaf has got charge when we have that charge around the plate and the leaf. So we have the charge around the plate and the leaf. So we can see that diagram which we have on there is trying to give us the basic steps or the steps on charging gold leaf electroscope positively. So can we try to move on now with these steps together? Who can tell me the first step here we're seeing in the first diagram here? See, the first step describes set of, some points here on how we can be able to charge gold leaf electroscope positively. We are seeing some negatively charged rod, which is here. Then we're seeing some positive charges, which are on the cap here. We're seeing down here on the plate and they leave some negative charges. But how can we form a statement, a reasonable, the scientific one from this? What is happening there? Who's going to go? Who's giving us an answer? And if can you have a trial of what is actually taking place there? the other time when we want to charge a single body negatively by induction, I mean positively by induction, what do you do? What kind of charged body do you bring near the body? If you want to charge a body negatively by induction, what type of charged rod do you bring?
Positively charged rod.
If you want to charge the body positively charged, you bring a positively charged rod. Is that what we said? So if you want to charge a body positively by induction, you bring a negatively charged rod. If you want to charge the body negatively by induction, one body by induction, you bring a positively charged rod. Now here we're charging this gold leaf electroscope positively by induction. So what we're going to do is we shall bring a negatively charged rod. So here, when a negative charged rod is brought near the cap of a gold leaf electroscope, you see the negative charged rod is brought near the cap of gold leaf electroscope. What happens is the negatively charged rod will induce opposite charges, because from the mode of operation we said it induces charges of opposite kind on the cap. And then these positive charges here, which are induced here, will repel these positive charges here will repel the other positive charges that were initially here on the negative charge rod if they were there to the extreme end. But because this body was just only a negative charge, so it induces positive charges here, and then the negatively charged rod here, the charges on the rod will repel the negative charges which were going to be induced by this body to the gold leaf and the plate. And these charges move down there through the metal rod. So a negative charge rod is brought near the cap. Positive charges are attracted, or they are induced on the cap, and negative charges are repelled down to the plate and the leaf. And then this is followed by seeing the divergence of the leaf. You can see now that from the diagram here, the leaf has diverged, which means the leaf is moving away from the what? The plate. Then after this, you have to earth the gold leaf electroscope in the presence of the charged rod, which now brings us to the second diagram. So you earth the gold leaf in presence of the charged rod. So the charged rod is still there. So as the charged rod is still there, you are seeing that they are saying brief electron flow. See, electrons are flowing. Which electrons are these ones that are flowing? I can tell you here that these are the electrons which are here on the plate and the leaf. Because there is no force that tends to keep them here, these electrons, when the cap of the gold leaf electroscope is earthed or it is touched, the negative charges here, which were on the plate and the leaf, will be conducted away to the earth. They will be conducted away to the earth using the earthing wire. So that is what happens. The electrons which are on the plate and the leaf will flow to the earth. Then eventually, on breaking the earthing connection and then removing the rod, which means two things are being done here. Break the earthing connection. After breaking it, you remove the charged rod. You'll find that these positive charges which were on the cap will spread out down to the plate and the leaf, and then you will see once again divergence of the leaf. So those are the kind of the trend of events that happen, or the steps in charging a gold leaf electroscope negatively, positively by induction. So I said they are just very brief steps. One is a negatively charged rod is brought near the cap of the electroscope. positive charges are going to be attracted to the cap. In another way, someone can say positive charges are induced on the cap, meanwhile, negative charges are repelled down to the plate and they leave. That is also correct. Then after that, what happens is the leaf will diverge because now the plate and the leaf have got what? The same charge. So on earthing, the gold leaf electroscope, in the presence of the charged rod, electrons on the plate and the leaf will flow to the earth. Someone will say, now, but why can't these charges which are just near here on the cap be the ones to be neutralized, or what? Why is it that it is the charges which are down? See, these positive charges here on the cap, they are being in a very strong electrostatic force of attraction, with the negative in any way be eliminated. This earthing here will make electrons which are from the gold. Importantly, you need to break the earth connection before removing the charged rod. So the earth connection has to be broken before removing the charged rod. Then on breaking the earth connection and then removing the charged rod, you'll find that these positive charges which are initially here on the cap will now spread out to the rod, down to the plate and the leaf. So eventually making the gold leaf electroscope to be charged positively, or it will now be bearing positive charges all over from the cap down to the plate and the leaf. So because when always in a body, we can just say the body has got a charge when there's divergence of the leaf. So, the only sure test for charge on a body is divergence of the leaf. So this is actually what we have looked at we're going to look at in our next meeting, if we shall have. So how we can be able to charge a body. The opposite, positive is negative. Now we're going to move on with this together, and you will now be guided by the diagram there. So we shall outline these steps together. I want us to start right from there. If we want to charge this body negatively, the gold leaf electroscope negatively by induction, what are the steps that we shall follow? Those who have been very active following previously what we did look at, what we did say on charging the gold leaf electroscope positively. Now here, it could be telling us the procedures that we do follow with the illustration that I have here. What is going to be the first step? What would be the first step?
Bring a positively charged rod near the cap of an uncharged gold leaf.
So, she's saying positive charge rod is brought near the cap of the uncharged gold leaf electroscope. Very correct. The next step, could you have someone also different contribute? And if I said positive charged rod is brought near the cap of the uncharged gold leaf electroscope, and that is very true. The next step. The next step. Uh-huh.
Negative charges are induced on the cup, and the positive charges are repelled down to the plate.
Uh-huh. Saying negative charges are induced on the cup, correct? And positive charges are repelled down to the plate and also the leaf. Is that okay? Which is true? Uh-huh. So what happens when now the positive charges get repelled down to the leaf and the plate? What will happen? Uh-huh. What will happen? What do you think will happen when the plate and the leaf have the same charges?
The leaf will diverge.
The leaf will diverge, correct? So we shall have the leaf diverges. Then when the leaf diverges, after this, what is the next step you will do? You will follow the divergence of the leaf. Now, first of all, we have brought the positive charge rod in near the cap of the uncharged gold digital electroscope. Then negative charges have been attracted or induced on the cap, and the positive charges were repelled down to the plate and the leaf. And these charges, which are down to the plate and the leaf, the positive charges, they had to move through the rod. Then after that, because the two already have the same similar charge, there will be some divergence. After that, what do we do?
The cup is earthed to neutralize the positive charges and repel
The cup is earthed. So we earth the gold leaf in the presence of the charged rod, and we do the earthing on the what? The cup, correct?
And a decrease in divergence of a gold leaf is observed.
So when the cup is earthed like that, you'll now see some brief flow of electrons. These electrons will come from the earth. These electrons will come from the earth, but they'll flow and neutralize the positive charges which are down here on the plate and the leaf. Because of the attractive force of the positively charged rod, the negative charges on the cup will remain there untempered. They will not be able to, they resist any force. So when the metal cup is earthed, the negative charges will flow from, or electrons, excess electrons which are in the earth will flow and neutralize the positive charges from the gold leaf and the plate. So as a result, you'll find the leaf will collapse. So the leaf collapses. So that is what we shall see. The leaf collapses in the second diagram. Now, what do we do in the last step on the last diagram? What are we going to do? In the last diagram, I want us to critically see that and try to give what happens there. Who's going to try to give an answer to that?
The earthing is removed and the charged rod and the negative charges on the cup distributes onto the plate and the leaf diverges.
Okay. Just like what? Then
the electroscope becomes negatively charged.
Correct. That you break the earthing in the presence of the charged rod. That's why we're saying the charged rod is now removed. And then after which you can take the charged rod. But you first have to start by breaking the connection when the charged rod is still in position. So after breaking, you remove the charged rod. So after removing the charged rod, now you'll find that these negative charges which were on the cap will spread out to the rod, down to the plate and the leaf. And then once again, you'll see some divergence of the leaf. Divergence of the leaf will imply that the gold leaf is already charged. But from here, we know it is already negatively charged because it is the negative charges that have got uniformly distributed on the gold leaf electroscope. Now, I want us to finalize by looking at the uses. What do we use the gold leaf electroscope for? What do you think is the use of the gold leaf electroscope? Joe is telling it detects the presence of charge on a body. Very good. Joe has given us that answer from the chat, to detect the presence of charge on a body. So if we want to, Leila is saying the same. So if you want to know when the body has got charge or not, you can be able to use the gold leaf electroscope, correct? Just like what I know, we already have got the basics. From there we have known, and we can even be able to predict how this is done. Another use that we can have out of gold leaf electroscope, because we basically use this for studying charges. Now we can use the gold leaf to test the nature or the sign on a body. Test the nature or sign of a charge on a body. When I talk of nature, there I mean whether maybe it is positive or negative, because we said sign, I mean charge takes two signs. It may either be positive or negative charge. So if you want to know whether this is a negative charge or a positive charge in relation to the nature of the sign from the body, or want to know whether this body is positively charged or negatively charged, you'll use the gold leaf electroscope. Is there another use that one person, someone will want to come up and answer from the chat? Good. We have we have from Hanifa here, to test the magnitude. To test the magnitude of the charge on the body. This answer, I can try to give it in another way as comparing and measuring potentials. See, if you want to compare, maybe there are two bodies, you want to compare the magnitude of the charges on the body, the size of the charges on the body, you can use the gold leaf electroscope. The potentials, you want to measure the extent, you see, there you can be able to use a gold leaf electroscope. And this, someone will be asking, how do we do it? It will depend on the size of or the size of the divergence of the leaf. You look at the level to which the leaf has diverged. When it has diverged very small for one body, then for the other one, it has diverged much, you'll be able to conclude that the body in which there's much divergence has more charges than the other body with small divergence. So that is how we can be able to compare and measure potentials. In other words, which Hanifa says, measuring the magnitude. And lastly, we can be able to use gold leaf electroscope to classify conductors and insulators. We can use gold leaf electroscope to classify conductors and insulators. This, insulators, when they are in their state, they do not actually have electrons, and there's no conduction that can happen when you happen to bring any insulator in contact to a body which has got charges. So when a gold leaf electroscope is charged and you bring an insulator here on the cap, and then you realize nothing has actually happened, you can be able to, first of all, give a premature conclusion there. You can say this is a body that is either not having charges or it is an insulator. It does not conduct charges. But you can move on to carry another test to determine whether this body has got presence of charges. So it will now be a confirmatory to determine whether this body has got a charge, the presence of charge on a body. That one you carry in order to find whether it is now a conductor or an insulator. So those are the four uses of gold leaf electroscope. And then I want to actually wind up by giving you some package here. And the package is, you're supposed to describe how the gold leaf electroscope is used for detecting presence of charge on a body. It is used for testing the nature or the sign of a charge on a body. It is used to compare or determine the magnitude of charge on a body. That is why we say the comparing and measuring potentials. And then lastly, is used to classify conductors and insulators. And this is actually your weekend package. It is your weekend package. You have to do this work and see if we can be able to drop it on my email. If you still do not have a restriction on our site, on our WhatsApp page, which I think may be valuable to you, you can drop it on my email. I'm giving you the email on my email on the chat, so you can find me on yanduamos@gmail.com. There it is. So you could be able to, you can be able to drop your weekend package there on that email, and you'll get the feedback. You don't be thinking very extreme. You can even just have this trail or this work done on a piece of paper. You use your pen, you write, you can have it written, and then with the diagrams, the illustrations should be clear. You do it on a paper, and then you only take by using you can use the camera of the phone, capture the image, and then I'll be able to use that image to work through and give you feedback. I think that is all I wanted to say for now. I hope I've been got clear and loud. Let me capture, and I'll be able to still put this in the WhatsApp group there for those those who are not on the call, but be able to try. I really thank you for listening and the active participation. Joy is saying yes. Leila is saying okay. Albert is saying okay, sir. I think all those are the feedbacks from the chat. I hope all the rest are going to do the same. And I think today is the last day of our free online lessons. So from after here, I think we are basically going to have many of our engagements here like this and more than the other services that you have not been able to enjoy for those who will have subscribed. We have already some message which is there on our WhatsApp group. I think we have to do from the management.